Okay, figure shows a combination of 3 capacitors where C1, C2 and C3. Okay, a 20-volt supply is connected to the combination. Okay, determine A, the effective capacitance in the circuit, the charge stored in C1, the potential difference in the C2, and energy stored in C3. Good. So let's start off with first question. Okay, effective capacitance. That means I need to find the the total capacitance. Okay, I need to find the total capacitance. All right. So we have C2, C3 in series. Okay, and then C1 is in parallel with C2, C3. Okay, so let's do it. Yeah, let's do the first question. We can see C2. First of all, we start off with C2 and C3. They are in series. Why we say they are in series? Because they have, you see, one leg connected. Like, let's say for C2, one leg connect with C3, one leg connect with C3, but the other leg of C2 connect to C1. Same goes to C3. Only one leg connect to C2, but the other leg connect to the C1. All right. So it's only one leg connection. One leg connection. So this is series, right? Okay. So series. For series equation, we remember series makes the capacitor smaller. Yeah, series make the capacitor smaller. If parallel capacitor make the capacitor stronger, series capacitor make it smaller. So it's 1 over C. Okay. So it's a 1 over C to 3. Okay. Equal to 1 over C1 plus 1 over C2 plus 1 over C3. Okay. So what's the value of C2, C3? You just put in 22 micro and 47 micro. Okay, 22 micro here, and then for C3 we have 47 micro, right? So let's calculate this one. Okay, I got this is 69 over 1034. Again, this is not the answer yet because we haven't invert. Okay, we haven't invert. So remember to invert the whole thing. Okay, invert this, and this is micro. Yeah. Oops. Okay. So what will we get? 1 divided by answer. So the answer is 14.9855 microfarad. Okay, that's C23, and then we between C23 with C1, it is in parallel. Okay, it is in parallel. Yeah, if you look at here, you see that this one, this whole thing, C23, one leg connect with C1, another leg also connect to the C1. So it's two leg connection. You see that? So I can say that C23 and C1 is parallel connection because two legs connection. Yeah, two legs connection. All right. Okay, so now let's do it. If parallel, okay, parallel capacitor make the capacitor stronger because it's plus plus plus. Yeah, parallel capacitor plus plus. So we can find the C total already. C total is C23 plus C1. All right, parallel capacitor is, the capacitor is plus plus plus. The total is capacitor is bigger. right? Okay, so the C23 is 14.985 micro plus C1. What is C1? 100 micro. So the answer is 114.99 microfarad. Okay, 114.99 microfarad. That's the answer. So I got the answer correct. 114.99 microfarad. Okay, so then let's find out the, okay, I want to rub this off. Okay, then what is the charge stored in C1? Okay, so this charge stored in C1, which is this one should be the Q1. I need to find the Q1. Okay, so question B, how to find Q1? How to find Q1? So okay, one thing I know, this is a parallel circuit. You see that? C1 is parallel with battery. C23 also parallel to battery. So I can say that between you can say V total because it's a parallel circuit. Because it is a parallel circuit, the V total is equal to V1 equal to V23. Okay. V total equal to V1 equal to V23. Yeah, when parallel circuit, they have the same voltage. So I can say that which is also equal to 20 volt, because the V total, this is the V total. You see that? This is the V total. V total is 20 volt. So the V1 should be 20 volt. Yeah, V1 should be 20 volt. So I got the V1. Now I can find Q1 actually using the formula. What formula? We can use a formula Q equal to CV. I already have V1. You see that? I already have V1 here. V1 here. So this one should be V1, and also C1. Also I have C1 here. C1. Okay, C1. So I can get my Q1. All right. So let's substitute. My C1 is 100 microfarad. 100 microfarad multiplied by voltage. V1 is 20 volts. So it is 2000 microfarad. Yeah. No, not microfarad. Charge is coulomb, microcoulomb. Remember the microfarad. So this one is microcoulomb, not just coulomb. Am I right? 2000 microcoulomb? Yes, 2000 microcoulomb. That's correct. That's the answer. Okay, next I want to find what's my potential difference in C2. So that means I want to find my V2. So how to find voltage 2? How to find voltage 2? Yeah, how to find this V2? Here we have V3, right? We have V3. This one we have this is V1. Okay, what is V2? What is V3? How are you going to do this? Let's look at question C. Okay, question C. I want to find V2. So okay, V2. What I can say is we have the V23 here, isn't it? V23 means the whole thing. Okay, maybe I should adjust a little bit. Yeah, my stuff here. What is this? Okay, I should adjust. Okay, what I can see from here, this over here, this is V23, right? This is V23. So V23 is V1, yeah, or V total. So okay, I write it over here. So V23 is equal to V2 plus V3. Am I right? Huh? And V23 itself is 20 volt. It is 20 volt. Okay, can I get the V2? Can I get the V2? I don't have V3. So I'm stuck. You see that? I'm stuck. I cannot find V3, so I cannot find V2. So I cannot do from here. So if I cannot use voltage, I use what? What do I use if I cannot use voltage? I need to change a little bit, change my strategy. I need to change using charge. If voltage cannot work, I change to charge. Charge my work. Okay, this is what you can say between 2 and 3. Between 2 and 3, it is I can say it's series circuit, right? I must write there series circuit. So for series circuit, the voltage is plus plus. Yeah, voltage is plus plus. For series circuit, voltage is plus plus. But for series circuit, the charge is equal. Look back to the notes. Capacitor in series. When capacitor in series, all the total charge equal. All the charge equal. You see that? Total charge equal to Q1, equal to Q2, equal to Q3. But the total voltage is plus plus. You see that? Series, the voltage is plus plus, but for the charge is equal. Charge Q1 equal to Q2 equal to Q3, because only one circuit. You see that? So the charge is equal. Well, how do I write? Q23. Yeah, I have Q23 will be equal to equal to Q2 equal to Q3. Because this series, I'm only talking about between C2 and C3. They are series, so all the charge is equal. So from here, I need to find what is Q23. Do I have Q23? I don't have Q23. What can I do? How to find Q23? So what you can do is I have the V23, right? I have the V23. Let's find it. Yeah, I have the V23 over here. V23 is 20 volt. Okay, I have the V23. V23 is 20 volt. So I can find my Q23, isn't it? I can find my Q23. Q23 is I just use Q equal to CV formula. And then I can just put the subscript there, 23, 23, 23, 23, 23, 23. Okay, so now I can proceed. I just put in my capacitance 23. Capacitance 23 is 14.9855 for 14.9855 microfarad. Okay, that is C23, and then voltage to 3 is 20 volt. 20 volt. Okay, so what do I get? 14.9855 multiply 20. So the charge is 299.71 microcoulomb. Okay, micro, still have micro there, because this micro come from the microfarad. Yeah, micro. So I have the charge already. I have the charge 23. So what can I say about the charge 23? Charge 23, it will be equal, because series, right? So charge 23 will be equal to charge 2 equal to charge 3 equal to Q2 Q3, because series, right? So I can write there also. So this I can write over here. Q23 is Q2 equal to Q3, which is also 299.71 microcoulomb. So right now I have the Q2, Q2 and Q3. So Q2 is also this charge. I want you to see it. Q2 I got it already, is 299.71 microcoulomb. So from there I can work some more. So Q equal to CV. This is Q2, C2 and V2. So from there I can find my V2. Which is for question C, V2. Okay, do it step by step. Eventually you will get it. So my charge 2 is 299.71 microcoulomb. My C2, capacitance 2 is 22 microfarad. 22 microfarad. And my voltage 2. Okay, so I can cut my micro there. Okay, so this one divided by 22. So my V2, my V2 is actually 13.62 volt. That's my answer, 13.62 volt. Is that correct? 13.62, 13.63 volt. That's correct. Almost correct. Okay, that's my voltage. Now I want to find my energy stored in C3. So I want to find energy stored in C3. That means I need the U3. So how to find energy stored in U3? Okay, charge already just now, and I can find my voltage from there, right? Okay, so let's go to question donkey. Yeah, let's go to question donkey. So I need to find U3. So to find U3, I need the formula half. I have several formula. I can use half, maybe CV square, or maybe half QV, or maybe any value I have, half Q square over C. Okay, so this is a energy stored in capacitor 3. So all this C3, V3, Q3, V3, Q3, C3, all 3. Yeah. So which value I have? So I just determine which formula I can use. I need to find U3. Do I have C3? Do I have C3? Yes, I have C3. So I must use one formula with C3. Do I have V3? Do I have V3? I don't have yet V3. Do I have Q3? Do I have Q3? Yes, I have Q3. You see that? I got my Q3 over here. So my Q3, so I can use this formula. So Q3, I got my Q3 is 299.71 microcoulomb. So I use this formula and I can find my answer. So I use this formula. My U3 is equal to half Q square over C. So my Q3 is 299.71 microcoulomb. 299.71 microcoulomb. Remember, the micro is got value exponent. Better write as value. Yeah, convert to value already, because now you have square. So you need to convert the micro into exponent -6. Okay, where divided by the C, which is C3, which is 47 microfarad. 47 micro. Okay, so what's the answer? Let's calculate. Yeah, 299.71 exponent negative 6 square divided by 47, 47 exponent negative 6, then multiply 5. Okay, my energy stored is 9.55 9.56 exponent negative 4 joule. That's my answer. Am I right? 9.56 around there, exponent negative 4 joule. 9.54 exponent negative 4 joule is almost correct. Yeah. Or you also can use the other formula. You can also use this formula if you know the voltage. I think voltage 3 also I can find, because you see that if okay, let's try the other formula, V3. Important, I need to find V3 first. Yeah, V3. I got V2 already. I know this one. These C2 and C3, they are in series. In series, so their voltage is plus plus. Understand? The voltage is plus plus. So V2, okay, let's do it. Yeah, V23 is 20 volt. V23 is 20 volt. Put 20 volt there. Yeah, 20 volt. And then V2 is 13.62. 13.62. Okay, what is V3? V3 is 20 minus 13.62. Okay, is 6.38 6.38 volt. Okay, so once I got this, I can use the formula half CV square, U3. Okay, use another way, U3 equal to half CV square. This time I use C3 half CV square. So my C3 is 47 micro. Put it 47 micro. Micro is exponent negative 6. Okay, farad. And then V3 is 6.38. Okay, square. So all right, let's do it. Yeah, calculate 47 exponent negative 6 divide 2. Okay, 9.57 exponent negative 4 joule. Am I right? 9.57 exponent negative 4 joule. Am I right? Yes, almost there. Yeah, you see, I get almost the same answer. So either way is you can use half CV square or half QV or half Q square over C. You still can get back the same answer. Alright. So that's all for this question. Okay, see you again. Bye bye.